A 50 kVA 50 Hz single phase transformer operates at 220 bar 400 volt. If it operates on 220 volt 40 Hz supply with secondary winding, then A. Both hysteresis and eddy current losses increases. B. Both hysteresis and eddy current losses decreases. C. Hysteresis loss increases while eddy current losses remain the same. D. Hysteresis loss remains the same whereas eddy current losses decreases. This question is based on the theory of EMF equation of transformer as well as constant losses of transformer. So we know that in a transformer we have two types of losses. Both of these together we call it as constant losses. Hysteresis loss is due to the reversal of magnetization of iron core because we are using AC power supply, and eddy current losses is due to the circulating currents in the core of the transformer. To minimize that, we laminate the core. So hysteresis loss formula is given by WH is equal to the coefficient of hysteresis N or eta, Bm raised to 1.6 FV watts, and eddy current loss formula is We is equal to N, again the coefficient of eddy current loss, Bm is the maximum flux density, Bm square, F square, T square, V watts, where T is actually, small t is the thickness of the material and V is the volume of the core. Now if we look at the EMF equation of a transformer, it is V is equal to 4.44 Fn V max into A, where A is the area of the core. And if you take a transformer, since N number of turns and A area of the core is fixed, we can say the flux density Bm is proportional to V by F. So now if you substitute the value of Bm, that is V by F, in the formula for hysteresis, we get the eta Bm raised to 1.6 FV watts. In that we are substituting the value of Bm, we get Wh is proportional to V raised to 1.6 by F raised to 1.6 into F. So if we take F downwards, we get V raised to 1.6 by F raised to 0.6. If we substitute the value of frequency, we have changed the frequency from 50 to 40. So in the first case it is V raised to 1.6 by 50 raised to 0.6. For second case, WH is proportional to V raised to 1.6 by 40 raised to 0.6. So when the denominator term is lesser, the value is greater. So the seventh equation is greater than 6. So we can say hysteresis losses increases when the frequency is decreased. The hysteresis losses will increase. Similarly, for the eddy current loss formula, W is eta B max square F square T square V watts. So Bm is proportional to V by F. Substituting, we get eta V square by F square into F square. So F square and F square will cancel off. We know that T and V, volume of the core, are fixed for the material of the transformer. So We is equal to NV square. That means since we are not changing the supply voltage, 220 volt remains the same, eddy current losses will remain unchanged. So the answer is C, hysteresis losses increases while eddy current losses remain unchanged.
You are watching HTech Tutorials. For more educational content, like, share and subscribe.